Think math.
A sine graph is a smooth, rolling wave. But the sine function gave us the coordinate of a point on a circle. A round circle and a rolling wave. They look nothing alike. How can these two be the same thing? Spin a point around the unit circle. Sine theta was the height of that point. As the angle grows, the point climbs, and then comes back down. So if you watch only the height, you get a value that rises and falls. Now the decisive step. Take that height and unroll it sideways, using the angle as the horizontal axis. Move right as the angle grows, and mark up or down by the height at that moment. Keep marking points, and that familiar wave appears. Now every feature of the graph is explained. When the angle is 90 degrees, the point is at the top of the circle, so the graph is at its highest. At 180, the point returns to the horizontal axis. The height is exactly 0, so the graph is 0. At 270, the point is at the bottom, so the graph is at its lowest. What happens after a full turn? The point comes back to where it started. The height is the same as at the beginning, so the graph draws the very same shape again. That is why the wave repeats, because the circle is closed. To sum up, the sine curve is not some newly invented shape. It is the height of a point going round a circle, laid out side by side in order. Unroll the circle and you get the wave. Roll the wave back up and you get the circle. A sip of math every day with Think Math.